All right, so yesterday we started talking about transformations of quadratic functions. And to do that, we had to start talking about the vertex form of the quadratic, which is this equation we have here, this f of x equals a times the quantity x minus h squared plus k. Now, one of the main things that vertex form does is it tells us what the vertex of the parabola is going to be. The vertex is the ordered pair h comma k. A, H, and K also tell us different things. A tells us which direction it's going to open, and A also tells us how wide or how narrow that the function is going to be compared to the parent function. H tells us if the function is going to shift left or right, and K tells us if the function is going to shift up or down. So each of those letters, A, H, and K, we call them parameters because they affect the function in different ways. So we looked at vertical shifts, which was our K value, and horizontal shifts, which is our H value. K shifted our function up and down. H shifted our function left and right. What we have to remember about H, when we have a minus inside the parentheses, that is telling us that H is positive, and it moves to the right. If we have a plus inside the parentheses, it is telling us that H is negative, and it shifts to the left. That is the hardest one. We looked at a couple examples. We said what the vertex would be for each of those and which way they were shifting. Then we looked at reflections across the y-axis and reflections across the x-axis. The difference is the negative in parentheses or not. If the negative is in the parentheses, then we have a reflection across the y-axis. If the negative is outside the parentheses, then we have a reflection across the x-axis. In other words, that's telling us, is it going to open upward or downward? Again, we looked at a couple there. And then we looked at vertical stretches and compressions and horizontal stretches and compressions. The difference between the two comes down to the parentheses. If there's no parentheses, then it's a vertical stretch or compression. If there are parentheses, it's a horizontal stretch or compression. And that A value becomes a multiplier. It depends if the multiplier happens before the square or after the square, depending again on those parentheses. So we were just getting to these practice problems. It says describe the transformations of f of x equals x squared for each function, then graph the transform function on the coordinate plane provided. Now, before we get started on these, I want us to remind ourselves what the t-chart for the parent function looks like. F of x equals x squared. If we were to do a t-chart, and we've done this already, this is what we ended up with. This is how we knew how to graph the points of the parent function. Now, all of these, again, are going to be transformations of the parent function. If it helps you, draw in the parent function on the graph and then transform it. So we have several things to look at in this first one. We have g of x equals negative times the quantity x plus 8 squared minus 6. If a is negative 1, that's what that negative out there is telling me. We have this negative, so that's telling me that a equals negative 1. What is that telling me about this parabola? It opens downward. If it opens downward, what kind of transformation has to happen from the parent function for it to open downward? Look back at your different examples. Which one shows a parabola opening downward? What is the only one that shows the parabola opening downward in the examples? I'm showing it on the screen where it's the only one showing it opening downward. What is that transformation? Reflection across the x-axis. So for it to open downward, that means we have a reflection across the x-axis. So we know this is opening downward because of that. Now we have to look at the other values. What does the +8 tell me? Is that a horizontal shift or a vertical shift if it's inside the parentheses? Is +8 a horizontal shift or a vertical shift? It's a horizontal shift. Which direction and how many units? If it is a +8, what is the value of h? Yeah, because h would be -8. If it's a +8, that means that h is 8, and we know that k is -6. So we're going to do a horizontal shift, 8 units left. And if k is -6, obviously that must be a vertical shift because we've already done our horizontal shift. So a vertical shift, which direction and how many units? 6 units down. So based on this information, what is my vertex? -8, -6. And if I know my vertex, then I know my axis of symmetry because it shares that x value. So what is my axis of symmetry? Again, it has to be that same value because that goes through the vertex. So what is my axis of symmetry? X equals -8. We need to make sure we're saying that x equals -8 is just a number. X equals -8 is a line. So we need to make sure we're saying that correctly. And you've already told me that this opens downward because of that reflection. So my axis of symmetry is at -8. Again, if it helps you, sketch in your parent function. Now, we already know it's opening downward, and I'm just going to sketch this in as a dotted. So that's my parent function. That means every one of those points needs to move 8 units left and 6 units down. So my vertex goes from 0, 0 to -8, -6. Those other points also have to be moved 8 units left and 6 units down, which would give me those new points, and that would be the graph of my parabola. So if it helps you, sketch in your parent function and then move it the number of units you say you're moving it. You don't have to do that step, but I'm finding from the questions I'm getting in the previous periods, that might be helpful to sketch in that parent function so you know how to move everything. Number 2, h of x equals the quantity negative x squared plus 2. So what is my a value in this one? And again, a is outside the parentheses, not inside the parentheses. So what number is in front of the parentheses here? Outside the parentheses. 1. There's nothing there. There's a 1, which we know that means our transformed parabola is the same width as our parent function. We're not changing the width. What is the value of h and k here? Is there a plus or minus number after the x inside the parentheses? So what is the value of h? There's nothing there. It's 0. We didn't add or subtract anything from x. What is the value of k? 2. We have to know those values to be able to describe. Now, the negative x squared or the negative x in parentheses, that is a reflection across the y-axis. But a reflection across the y-axis doesn't change anything because it lands on top of the original. We said h is 0, so we don't have a horizontal shift. How would I describe my vertical shift? Two units up. Vertical shift, 2 units up. It's a plus 2, so 2 units up. So my vertex is what values here? Again, it's hk, so it's 0, 2. What is my axis of symmetry here? X equals 0. And does this open upward or downward? Is A positive or negative? So it opens upward. So you notice my axis of symmetry does not change on this one. It's going to stay my y-axis or my x equals 0. Again, if it helps you, sketch in your parent function. And again, I'm sketching it in as a dotted because I'm really moving it, but I'm showing that that's what we are moving. Really, all you told me to do was move everything up 2 units. So my function would look like this. It's just the parent function shifted up 2 units. Yes, it's a reflection across the y-axis, but we can't show that because when we reflect it across the y-axis, it lands on top of itself. So there's not really anything to show there for that one. Now, the third one is probably the toughest one we're going to look at because there is a stretch factor in the third one. So that one is causing a few more problems because we have to think about stretching it before we can move it. So number 3, j of x equals 4 times the quantity x plus 2 squared minus 6. So what is the value of a in this 4? What is the value of h? Negative 2. If it's a plus in there, it means h is negative 2. What is the value of k? negative 6. So right there, you already know the vertex. What is the vertex? Negative 2, negative 6. By listing out your H and your K. But let's talk about that 4 in front. That 4 means that we are stretching our original quadratic function. So we have a vertical stretch by a factor of 4. And if H is minus 2, what is that telling me? What kind of transformation is happening there? H, is that a horizontal or a vertical? Say horizontal shift. Two units left. And then I have a vertical shift. Six units down. So you already told me my vertex is the ordered pair negative 2, negative 6. What is my axis of symmetry here? X equals negative 2. And does this open upward or downward? A is positive, so it opens upward. So if I draw in my axis of symmetry at negative 2, now this is a little tougher. I know my vertex is at negative 2, negative 6. But how do I get my other points if I have a stretch factor of 4? What I have to look at, I have to look at f of x equals 4x squared. So I'm going to do a 3-column T-chart here. I'm going to do x, I'm going to do y, and then I'm going to do 4 times y, which is what we're really doing here. So we already know our x, negative 2, negative 1, 0, 1, 2. Our y's were 4, 1, 0, 1, 2. I have to take everything in that y column and multiply it times 4. What is 4 times 4? 16. 1 times 4 is 4. 0 times 4 is 0. So if I were just to graph 4x squared, those would be the points I would use. But I have to move every one of those points 2 units to the left and 6 units down. So 2 units to the left of negative 2 would be negative 4. 16 minus 6 would be 10. So at negative 4, I'm up here at 10, which means at negative 1, if I take 2 units, I'm at negative 3. Four minus 6 puts me at negative 2. And then I mirror those points to get that stretch. Boy, I'm not doing a good job of drawing that in. They'd like to see you in counseling right now. And he said you didn't need to bring your stuff. He's like, it was I asked him, he said you didn't need to, like it was going to be a brief conversation. I mean, if you want to, I'm not going to stop you, but. So again, I know those multiplier ones are going to be the toughest ones because we have to think of what would the multiplier look like before we transformed it. All right, P of x equals the quantity 1/4 x squared. The 1/4 is inside the parentheses here. Inside the parentheses. So this is going to be that horizontal because it's ax, the quantity ax squared. The a is inside the parentheses with the x. In this case, a equals 1/4. There's no plus or minus number after the x, so h is 0 and k is 0. We are not doing any horizontal shift or any vertical shift. There would have to be a plus or minus number after the parentheses for k. So here we have a horizontal stretch by a factor of 1/4. So in the previous problem, we multiplied times 4. Now we're going to be multiplying times 1/4. So again, I can create a 3. So I have x, I have y, and then I have 1/4 of y. So if I take my original t-chart here, that means everything in the y column I have to divide by 4. 4 divided by 4 is 1. 1 divided by 4 is 1/4. 0 divided by 4 is 0. 1 divided by 4 is 1/4. And 4 divided by 4 is 1. So my vertex did not change. My vertex here is still at 0, 0. I did not do any horizontal or vertical shifts, which means my axis of symmetry is still at x equals 0. And because a is positive, this is going to open upward. So I draw in my axis of symmetry. My vertex stays at 0, 0. So at -2, I'm up here at 1. At +2, I'm up here at 1. I'm not going to try to graph the 1/4, but I am going to add another x value. I'm going to add 4. Originally, 4 squared would be 16. 16 divided by 4 would be 4. So at 4, I'm up here at 4, just to help give me a little bit more shape. So you can see that 1/4, how it's making my graph wider. All right, we are also going to add the activity after this, transforming graphs of quadratics, because it's really I took only one page of the activity, which is really kind of the wrap-up page, which I think helps wrap up these transformations we've been talking about and simplifies them a little. So we are going to go on to page 25 and make this a part of what we've been doing. So it says, below are 6 single transformations, each done to the basic quadratic equation y equals x squared. And we should know that y equals x squared is the same thing as saying f of x equals x squared. For each graph function, name the transformation and record the equation. There's a couple extra words in here. Record the equation of the new function using what you discovered in the previous lesson. Now, I'm going to highly suggest you take out the toolboxes we have, use colored pencils, use highlighters, whatever, to color in these different graphs so that they stand out. The parent function is on this graph. I'm going to use yellow highlighter to show the parent function here because every transformation is being compared to this parent function here. So I highlighted the parent function here in yellow. Whether you want to highlight it, use another color. There should be highlighters in your toolboxes. You do not have to use the same colors I use. Don't try to match me color for color. You can use whatever colors you want, but I do suggest we do these in different colors so that they stand out. So after I've highlighted my parent function, there's nothing else for me to do after I highlight that. It's just showcasing it so I know that all the other transformations are being compared to that. So function A, I'm going to highlight that in green. And to show so I know what color, down here next to the letter A, I'm going to color that green so I know that that's the graph that I am talking about. So I'm showing what color I am using to highlight. So they want us to describe the transformation. Now, we do need to notice they are not counting by ones on this graph. They are counting by half. You have to look at how they've labeled the graph. So each of those grids is counting by a half. So what direction did graph A move? Did it move up, down, left, or right? In comparison to the parent function, did graph A move up, down, left, or right? Up. And how many units up did it move? Again, it's counting by a half. We have to pay attention to the scale. So it is 4 grid marks, which would be a total of 2 units. So if we're moving up, is that a horizontal shift or a vertical shift? It's a vertical shift. So down here in the name of the transformation, we would put vertical shift. Two units up. And then they want me to write an equation for that function. Well, that would be f of x equals x squared plus 2. All I did was change my k value to be 2 units up. I did not change my x value at all. So that would be f of x equals x squared plus 2. Graph B, and I got to shrink my screen down a little here to get all of B in the same screen. It's the largest one here. I'm going to use my purple to highlight graph B. And what type of shift happened to graph B and how many units? A vertical shift, 5 units down. So we have a vertical shift, 5 units down. So what would that equation look like? We shifted up 2 and we said f of x equals x squared plus 2. So if I'm shifting down 5, what would my equation look like? F of x equals x squared minus 5. All we've done is change the k value. We did not change the h value, so we can just do a plus or minus depending on what direction the graph is moving. Function C, I'm going to highlight that in light blue. So what kind of shift happened here? A horizontal shift. How many units in which direction? Horizontal shift. 2 units right. So how would my equation look like to show that shift? This is where it's going to be f of x equals parentheses x. Am I going to do a minus 2 or a plus 2? Minus 2, because I'm moving to the right, which means I'm putting a positive h value in. So the quantity x minus 2 squared. Okay, graph D, I'm going to highlight in, or I'm going to color it in my orange. So how can I describe the transformation for graph D? Horizontal shift. Horizontal shift 4 units to the left. So what is my equation going to look like here? Yeah, parentheses x plus 4 quantity squared. Because I'm moving to the left, that means I'm putting in a negative h. So I have to do x plus 4. Graph E, I'm going to highlight in my dark blue. What type of transformation happened to graph E? A reflection across what? Yeah, so this is a reflection across the x-axis. Which means that it would be f of x equals negative x squared. That's how it moves down. We have that negative out front. We're not squaring the negative. It's not inside the parentheses. It's out front of it. So it is flipping it across the x-axis to open downward. We are not going to worry about graph F because that is nothing that I'm going to test you on or that we're going to deal with. So I'm just putting a line all the way across F, and I'm not going to highlight graph F there, which you can notice opens up to the left. It's sideways instead of up or down. But now we do have this final conclusion. Again, the generic vertex form of a parabola is y equals a times the quantity x minus h squared plus k. From what you have learned, describe what each of the following changes to a, h, and k will do to the graph of the quadratic function. And I'm not looking for horizontal and vertical. I'm just looking for very basic terms here. If k is greater than 0, does that move my graph up, down, left, right? If k is greater than 0, so if k is a positive value, what direction does it move my graph? Okay, remember it's plus k. Look at your formula right here. Where is your k value? K is that last one. That affects your up, down. So this moves your parabola up. So if k is negative, what does it do? Moves the parabola down. If h is a positive value, what direction does it move the parabola? Now, we're not talking about the equation. We're talking about just the h value itself. If h is positive, it moves the parabola to the right. Remember, if h is positive, it would be x minus a number, so it's still moving it to the right. If h is negative, it moves the parabola left. If a is greater than 1, the parabola is narrower. And if a is between 0 and 1, the parabola is wider. So that helps you kind of sum up everything we've been talking about. How are each of those letters affecting the move in what direction?